by way of introduction, I was invited to go to Angola by the Mines Ministry to give this talk in its original version, which was on the 25th of November last year. That was on the first Angola International Diamond Conference. It was a heralding of a new era for diamonds in Angola. And it was a privilege to be there and see the development since I was last in the field in Angola, which was around 2006, 2007. So I actually used the opportunity to go into the field just when Omicron hit South Africa. And it was a very useful visit at that time to renew myself with the terrain. This front piece here has a diagram on the right-hand side, which is attributed to Maggie Loubser. It was commissioned by De Beers. And it's it shows crater facies kimberlite, both erupting, the huge volcaniclastic cloud, and preserved with lenses of crater facies material in here. It turns out that that environment is very well preserved in the Angolan setting. And so this diagram on the right-hand side is a very useful sort of prompt to what I will be talking about during this talk. The title of the talk is The Geology of Angolan Kimberlites, and there's sort of an add-on at the end, and diamond quality compared to regional production. This is actually the topic they wanted me to cover during the conference, and I do cover it in 3 slides right at the beginning by talking about diamond quality and in particular dollar per carat values. And as you can see in the picture on the left-hand side bottom, diamonds vary in quality and therefore also in price point. I'll show this diagram on the left-hand side here, which is diamond prices in US dollar per carat for the past 4 years. This is a lot of data that I've compiled from various different sources. And notice there are 4 different colors on this graph, which is a log scale graph. It's a log 2 scale graph because diamond prices do vary over a huge range from very low to quite high. The colors in gray are Kimberley process certificate numbers. Those are publicly available. In green, they are from a primary kimberlite pipe. In blue, obviously, is an alluvial production. And we'll see a bit more data in orange. These are for the type 2 diamonds, of which Ray Ferraris gave us a good talk yesterday. And so on the first diagram on the left, we have all 4 colors represented. And starting at the bottom there, you can see that the price point for diamonds from Catoca in bold green is similar to the global price for diamonds, the KPC diamond number. There is a higher quality in 2 other pipes. I just want to get my pointer going here. These are them over here in green. This one over here is Kamutwe. It's a low-grade producer, but it's got very nice diamonds in the north of Angola. This one here is Kamachia, formerly known as Lulo. It's got a slightly lower price point. More recent data has pushed this price point up, but it's useful to know that the alluvial diamond price point that you see in Angola is covered by producers that have similar quality diamonds, at least in terms of price. Then talking about the alluvials, there are 2 major alluvial producers. You can see them here, their price points. I'm not going to give their names. And then there are other minor alluvial producers in Angola, and all of their price points are in this sort of bracket over here, the alluvial bracket, which is similar to at least 2 primary sources that we know about. If you look at the integrated price for KPC Angola, which is this over here, then it's a blend of, it's weighted roughly 80% Catoca plus 20% alluvials to get you into this price bracket over here, just above $130 a carat. And then in orange, right at the top of the graph, we'll speak a bit about that project as this talk evolves. There are type 2 diamonds at Lulo. They fetch really high prices. And so they've attracted a lot of attention. It's a prime product that's now coming out of Angola. If we now compare the prices that we have for Angola production on the left with the SADC region, that's the Southern African region. I've got select dollar per carat values over here. And then let's start with the big guys. We don't have any dollar per carat prices for De Beers mines in the region. De Beers does not publish those numbers. They never have. But if you look at the Kimberley process certificate for South Africa and Botswana, that obviously reflects these major producers that are in the De Beers stable, Jwaneng, Araba, also Felicia. And you can see that there's the KPC for Botswana. That's the integrated price point for Jwaneng plus Araba combined, plus a little bit of Karowe. Here's the integrated price point for South Africa production. That's mostly Venetia, but then also a number of other producers. And these two price points over here are exactly similar or broadly similar to what you get out of Angola. So in terms of the average diamond quality that we're getting out of the Southern Africa region, it's in this region over here, and it has been like that for the past 4 years, at least the years that are now represented in KPC numbers. Kimberley and Finch together are operated by Petra. There they are over there. Primary producers. The numbers have dropped off over the past couple of years, in particular at Kimberley, but also at Finch, in terms of the price point that they're getting for their diamonds. But the price point they've been getting out of Kimberley and Finch has been very similar to what they're getting out of Catoca over these years. And I don't think a lot of people realize that this is the actual situation with diamond prices for these two primary producers in Southern Africa. There is a big difference though. Catoca is an open pit operation. Kimberley and Finch are long life underground operation. And so the profit margin on that price point, the revenue that you're getting from your diamonds, is actually quite different for these two producers. We can think of Kimberley and Finch becoming marginal operations. That's definitely the case. Petra has recently disposed of Kimberley for that very reason. But Kimberley is holding its own under private ownership, and that's a good thing for South Africa. Moving on to alluvials, you can see we don't have very good data for alluvials in Southern Africa. It's a very fragmented industry. I managed to get some data from Transhex, which has now been delisted. Their Barken product was very high quality. Their Richtersveld product was also decent quality. Shallow water, that was from some Namibian operations, was mid in the price point over here, and then the West Coast operations were slightly lower in price point. But we have to remember that Namibia's KPC price point is basically all alluvial diamonds. They are very far traveled, but it's a placer alluvial, and you can see that's at about $490 a carat, very consistent through these 4 years, which is in the same price point that you get for alluvials in Angola. So there's a different way of looking at the diagram on the right here, and that's by orange washing it. In other words, let's look at the distribution of diamonds price points, average price points for producers that produce type 2 diamonds in the SADC region. That's what this picture then looks like. Everything in orange on the right-hand side produces type 2 diamonds. So let's start at the bottom here. That's Cullinan. It's famous for some very, very nice type 2 diamonds, but the average price point for diamonds coming out of Cullinan is this price point that you see over here. Those are numbers from Petra's annual reports. And so the proportion of value in the total production from Cullinan that is attributable to type 2 diamonds is relatively small. Williamson in Tanzania, also previously known as Madui, is a well-known producer of type 2 diamonds, in particular bubblegum pinks. And we can see a slightly higher average price point for Williamson over these years that I were able to get data from. And then there's a range of Matai, Karowe, Koffiefontein. These are all producing type 2 diamonds in this range, roughly about $500 a carat on average for the production on an annual basis. The standout type 2 producer in Southern Africa is Letseng. Interestingly enough, the diamonds that they're producing from Letseng, it's their main money-making characteristic, is a similar range as what we get out of alluvials at Lulo. Interesting fact. So the question is, where is all the orange in the rest of the Angola profile that we see on the left here? We're expecting to see some orange in some of these sources over here. I think they have largely been unrecognized in Angola. There may well be, or in fact, there have to be primary sources in Angola that also produce type 2 diamonds, and which then end up in the alluvials. We just haven't found them yet. And we can do a little bit more diamond inclusion studies and research on the actual productions coming out of Angola to be able to elucidate the proportion of type 2 diamonds that are masquerading as other diamonds in this part of the diagram here. So I won't say anything more about diamond quality, but this is a very useful way of looking at diamond quality from Angola in comparison to the rest of the Southern African region. So let's move on to geology. The benchmark for geology of kimberlites in Angola is Catoca, and it's because it's been going for such a long time. They started it up in 1995. The numbers you see at the bottom there goes up to, in the table, goes up to 2020. If you go look in Catoca's annual reports, all these numbers are available, right down to the price points, the grades. And so we know that in this period, while this open pit was getting deeper, they've mined out 186 million tons of ore. And they've done so at roughly $65 a ton. And they've made good money. Their internal rate of return is about 15 to 20% at $65 a ton. But the interesting fact that a lot of people don't realize is in the same period, they've mined out 330 million tons of what they call sterile. 180 million cubic meters, 330 million tons of internal waste. This is crater-facies material that has come out of this open pit, and it's taken them 26 years to do so. So let's go look at that in cross-section. Here's the plan view that you've seen in Google Earth images in the previous slides. And you can go to an 11 IKC abstract by a guy called Vladimir Pervov and João Felix. João Felix is the chief geologist at Angola, at Catoca. And they've given us a very useful cross-section of Catoca. Let's look at the geology. Unit 1, which is this light blue material over here, is the primary volcaniclastic kimberlite. These are ore reserves. They lie in the future of Catoca. We'll see that in a moment. Units 3 and 4, which are these green and pink colors. It's a resedimented, it's a rim of resedimented volcaniclastic kimberlite. It's ore, 186 million tons of this stuff has been depleted. And it forms an annulus around the outside of this big open pit. Units 5, 6, and 7 are crater sediment. That's the stuff in light brown and the stuff in yellow. It's a crater basin that's sitting right in the middle. John Ward described something similar sitting in the middle of Kao, except it was filled with basalt. In this case, it's filled, in the case of Angola, it's filled with sterile sand or mudstone. 330 million tons of this stuff has been excavated. Crater sediments. So, right now, the open pit at Catoca, after 26 million years of mining, is at about a depth of 240 meters, which is over there. And so the future of this open pit is in primary volcanic clastic kimberlite with no crater facies material or dilution in the picture. And right now, Catoca is very likely starting studies for underground mining to access this material down here. And that's going to cost a lot of money. And so one has to think about that very carefully. If you look very carefully at this extended abstract from Vladimir Pervov, he says that 35 of 70 pipes near Catoca contain craters with sediment infill. 50% of the kimberlites in the area around Catoca that they have worked on at Catoca have a plug of crater facies waste material that's sitting in the middle of the open pit. And so there's a massive economic impact of about 200 meters of post-emplacement erosion. In other words, this is 240 meters deep. If you eroded this down by 200 meters, it would make a big difference to the mining and operability or profitability of an open pit mine in Angola. And we will look at that problem as we go through the talk. So we jump to the southwest of Catoca to a project called Alto Cuilo. Here's just one cross-section from a kimberlite called OC16, Alto Cuilo 16. I'm just showing this cross-section. It's a very big kimberlite because it has a similar structure to Catoca. There's Kalahari sand sitting over the top. There's about 40 or 50 meters of that. Then there's crater-filled sand, that's waste. There's some resedimented volcanic clastic kimberlite. And interestingly enough, also interpreted a fairly horizontal upper surface to what is called primary volcanic clastic kimberlite. And one of the things we've done at Alto Cuilo is we've relied a lot on magnetic logging. So you can see some profiles downhole of the magnetic signal of the kimberlite as we logged it. Obviously, the Kalahari sand has no magnetic signal. The crater facies sands have very little, but here and there you can see little bits of kimberlite. There's a bit over there. There's a bit over there, a bit over there. And then similarly through the resedimented volcanic clastic kimberlite, you can see how variable the proportion of sand to kimberlite is in that part of the hole. And once you hit the primary volcanic clastic kimberlite, it's all fairly magnetic. So that's a very useful aid in logging. But there are also other useful geophysical signals. You can use gravity, EM, and then I've forgotten the fourth one. But we used magnetic logging a long time, very, very effectively. I've covered the Kalahari cover and the crater infill. It impedes access for testing. In other words, if you want to get to the primary volcanic clastic kimberlite, you have to drill through, in this case, about 200 meters of other material just to reach your target over there. And in a mining scenario, all of this would be pre-strip, and that will cost money, capex. Out of AC16, there were low grades where we were tested. And where the tests were basically on the edge of the kimberlite system over there. You can see there is AC16 in this magnetic image on the right-hand side, and it outcrops in the river valley over there, and that's where we tested it. Where we did test it, there were good quality diamonds. You can see the picture of the diamonds over there. So potentially if the grade and other parameters could be improved, we would still be operating at Alto Cuilo, but we are not. There are many more large crater infill pipes on this particular concession, and there's more testing needed to prove up which one of those is usefully exploited in the future. I just want to emphasize that point by putting up a little table. Catoca is 64 hectares in size. Here are a couple of others at Alto Cuilo, including AC16, which are much larger. And you can see them on this magnetic image, which is published by Wayne Pettit, 2009 in Lithos. There's AC71. There's AC70, 150 hectare kimberlite. AC98 is huge. There's AC16, and so on. We'll see more of this type of thing going on in a little later in the talk. When you drill these kimberlites, this is the kind of rocks you see. The horizontal bedded crater facies sandstones. We've seen some stuff like this. In this particular section is in fact 320 to 380 meter depth. Think about that for a moment. Here's RVK with Cassange blocks. That's basically Karoo sandstone or Karoo siltstone. It's this reddish color over here. It's the country rock, and it forms a diluent inside the RVK. And then once you get to depth, you get to these primary volcaniclastic kimberlites, very uniform, good magnetic signal, clean rock. And that's often, you know, what you want to determine the grade and diamond quality of, but it's, in this case, it's very difficult to reach. We're skipping to the northwest of Catoca now to go to Camafuca, Camazambo. Just the point I need to make here is very large, very deep, low-grade craters are preserved. There's an inferred resource, very low grade, but a lot of it. Over the 0 to 150 meter depth at the Southern Era 2000 drilling. Nothing has happened to these kimberlites since 2000 because of this sand crater-filled sand-filled crater problem, and how you turn that into an economic resource. There are obviously other kimberlites around Camafuca, Camazambo. Not very little is known about those kimberlites. I expect that some of them will be have sand-filled craters, others may not, and we'll see the reason for that in a moment. Down south in central Angola, De Beers in their previous exploration drive did an excellent job on the Dando Kwanza concession in the B province. They discovered 39 new kimberlites, and reconfirmed 5 legacy pipes during this period. They're smaller pipes, they're less than 1 to 17 hectares at surface, and 14 of the 44 that were tested for microdiamonds had low grades. But the interesting part of their publication is they indicated 2 levels of erosion within the pipes that they did discover. And so diagrammatically, this is what that looks like. You know, soon after eruption of the kimberlite, you erode off this tuff ring, and then you're left with this brown stuff, which, guess what? That's crater facies sands and RVK. Down here is the primary kimberlite. And if you erode, in their case, 250 meters off, then you end up over there. And what you've got exposed at surface is the primary kimberlite, and you've removed all this diluted crater facies sandstones. Erosion has a very important role to play in the view of what you want to go exploring for. If you go for big kimberlites in Angola, you're very likely going to end up with a sand-filled crater problem. If you go for the smaller kimberlites, that sand-filled crater may well be eroded away. So let's see how that plays out in a different project in Angola. It's the Lulo project. And just by way of orientation, 30 kilometers to the east is the boundary of the Alto Cuilo project. And let's look at this, this topographic map of Lulo to begin with. This plane, this peneplain at the top here, that's at 1,200 meters above sea level, which is much like Alto Cuilo. And these are Kalahari sands, and then you go through the Kalonda stratigraphy. This is an eroded basin. You can see the erosion. Down here, we're at 1,000 meters above sea level. So there's 200 meters of landscape erosion. And as luck would have it, the Lulo project has a huge amount of kimberlite targets right in this river valley. Over here, we'll see their magnetic image in a moment. But to add to that inventory of kimberlite, they also have a lot of very nice diamonds in this river called the Cuilo, which they are mining. This is their alluvial mining blocks in red. And what they're getting out of these alluvials are these diamonds over here, including a large amount of type 2s. And they have 28 legacy pipes on this concession and an AMAG survey with about 250 targets. Before we get to that AMAG survey, let's just look at what they've been doing in terms of alluvial production since 2015. These are again data that are available in their annual and quarterly reports. So we can see how many special diamonds they are recovering out of the carats they're producing. It's becoming quite consistent as a proportion of their total carat production. What is not that consistent is the average price point that they're getting for their alluvial diamonds, because one of these large diamonds can have a very variable $1 million number attached to it. Back to the geology, and in particular, the aeromagnetic survey from Lulo 2008. They did a AMAG survey. There are many, many large kimberlites on this concession. Here's the strip that they chose to fly with detailed AMAG. This is their alluvial production scenario that I've just highlighted. The block in yellow over here is highlighted at the bottom over here. Look at these numbers: 30 hectares, 9 hectares, 29, 30, 34, 21 hectares. Very large, many, many large kimberlites. However, we know that there's 200 meters of landscape erosion over here. I just have to make these points on the sides to test and prioritize and bring to book these large kimberlites. It's a huge geoscience challenge, but it's also an incredible corporate challenge. There are partners, finance and legal, strategy and timeline that you have to all get right to be able to bring these resources to book. And just to emphasize that point, look at the timeline over here. They knew about these magnetic targets in an AGM in December 2010. This is their kimberlite exploration update 2020. It's already 10 years past before they actually started to get to grips with these primary sources. When they do, and they drill them, what do they find? They find kimberlites that have been eroded. So they don't find a big thickness of crater facies or RVK. It's about 40 to 100 meters when they do drill them. There is some PVK at surface. And we can confirm that the craters here have been eroded by about 150 meters. And so it supports bulk sampling of the non-sandy RVKs and the primary volcaniclastic kimberlites that are a prime target for kimberlite exploration in Angola. This is what that looks like. Here's some 2 bulk sampling pits. They're actually sampling primary volcaniclastic kimberlite in both of these pits. And so they can do that because this is accessible. It's not sitting underneath hundreds of meters of sand. So far, they've tested 4 pipes. I think they're shown in initial processing complete in green on this image over here. these light green ones, those are the ones they've tested. They have recovered type 2 diamonds, but they have very low grades at this time. Wait up, we'll hear more about this project in the future. You can see that in their update over here, this is their Q1 2022 activity report. They have big plans. And we will hear more about this project as time evolves. I just wanted to give some low-grade context. The previous slide had some very low grades on it. I just want to give some low-grade context here, and the low-grade context comes from northern Lesotho, where we know that you can develop very large open pits, because this is a Google Earth image of the Tseng main and satellite pipes, where a grade of less than 2 carats per 100 tons at a very high price point gives you a revenue of $35 a ton. At Matai, the revenue is about $20 a ton. And as of yesterday, I got some numbers for Kao, roughly 4.5 carats per 100 tons at $331 a carat. They are sustaining themselves as potentially a marginal operation, but doing so by paying attention to their geology at a revenue of only $15 a ton. So that's the break-even point, or very close to the break-even point for Kao and for operating a mine in the northern Lesotho context. And I don't see any reason why that couldn't be the break-even point for a mine in Angola. They're like what Lucapa and their partners are exploring at Lulo. However, there's some other things that you have to bear in mind. There are many other kimberlites in Lesotho, as we can see on the right-hand side over here, by the red symbols, where there are no diamonds or diggings on top of the kimberlite. In other words, there's a lot of barren material around when you're dealing with this low-grade context. And so you have to pay attention to differentiating things that don't matter from things that do matter, which is a challenging task all of its own. I just have a thing on the side here, on the right-hand side. That's a stamp that was issued by Lesotho in 1971, during the time of the first international kimberlite conference. They recognized that in the Lesotho highlands, they had the remnants of kimberlites that were once much larger, had crater facies on top of them, and that they were eroded. And so we are playing out the same game in Angola, and it's kind of iconic that it comes around after this amount of time. I just want to point out the location of Sekamang. We'll be talking about that tomorrow or the day after. Second last slide in my presentation is about the future of Angola and diamonds in Angola, and the future is very closely tied to this kimberlite called Luele. It's on the Luashi concession, so it's known as the Luashi, either Luele or Luashi. If you look on Google Earth in December 2020, you will see there's another open pit starting up. It was discovered in 2012, 2013. By March 2016, they claimed it to be a 100-hectare pipe, 55 meters of cover, roughly 1 carat per ton grade. December 2019, they had spent $200 million on this project. They stripped 20 million cubic meters of sand to collect a 450,000 carat bulk sample. At that time, they assessed the diamonds at $90 a carat, which means the revenue potential is around $90 a ton. You know, obviously, you can make good money on that. You just have to build the mine first. This is how much they've drilled. As of March 2021, they were aiming for 5.7 million carat production in 2023, and eventually it will be a 400-meter deep open pit. That's another thing to look forward to in Angola. I think we've covered the first point nicely. Diamonds from Angola are very similar to what we see in the rest of the SADC region. There's a very high quality at Kumutwe. More of those can be discovered. There's exceptionally high quality at Lulo. We believe the primary sources are nearby. Finding them and constraining them is going to be an interesting exercise. It's something we have to watch. Kalahari cover and sandfill craters, they restrict economic outcomes. They are present in Angola. They restrict economic outcomes because you have to dig them out, but it can be done, as has been demonstrated at Catoca. They restrict access for bulk sampling. So from an exploration point of view, this is a problem you need to resolve. And erosion has a massive impact on the way you view kimberlite potential in Angola. The diamond sector in Angola has undergone and is still undergoing a revival. In September 2011, they put a new mining code and mineral investment contract in place that gave you security of tenure. It's a huge step forward. In July 2018, they had a new rough diamond sale and marketing policy. That's changed the game a lot in Angola. And as of August 2021, there's an $80 million diamond hub that's been opened in Sarimo. There's a picture of it. That's a manufacturing complex and cutting and so on. Thank you all for your time. I think that's the last slide.
Thank you very much, Herman. That was very enlightening. Very well illustrated talk. Very interesting. We can open the floor for questions and comments.
Okay, thanks, Herman. Thanks for an excellent day from everyone, and thanks for a good presentation. I mean, just a comment from me to them. We obviously have a very similar situation in Southern Africa, particularly sort of going west of or going off Cratton towards Prisco with all our alluvial deposits. And if you see what Angola's done, you beg the question, why aren't we doing the same in South Africa? And again, if you see the investment that's going into Namibia, why don't we do the same in South Africa when it comes to particularly our alluvial diamonds? And hopefully next week, Lyndon de Malon and some of the alluvial guys will just will certainly highlight the potential of that area.